2 of our US, Canada, Latin America time zone. So welcome back if you were out for a few hours last night. And let's continue the show. All right, so we're going to have our second keynote in a few minutes. So today we're going to hear from 3 women working on a super cool project, Girl Gang Garage. I am personally very excited for this talk. Not only Girl Gang Garage mission is inspiring, elevate, encourage, champion women's entry and advancement within the automotive and skilled trade industries, but yeah, also incorporating 3D printing. So what can we ask more for? So I do know some of you are familiar with the organization, but you might not know all the 3D printed parts they do and all the cool parts they do and incorporating into their cars. So today we're going to talk about those parts and specifically about the Iron Maven project. All right, without further ado, I will introduce our 3 speakers and then I will ask them to come on stage. So we're really fortunate today to have Bogie Latainer, the founder of Girl Gang Garage, who will share with us her story and how she came to start the organization. Anne Pauly, who will touch on the 3D printed components used at Girl Gang Garage, especially on this project, the Iron Maven project, and Pam Waterman, who will share more about the 3D scanning techniques they used in the project. So bear with me a half second. I'm gonna get them all on stage. Bogie, if you want to turn your camera on, that will put you there. Here we go. And your turn. And then Pam, bear with me half a second. There we go. So Pam and Anne, if you want to turn your cameras on, again, that will put you on stage with us. Awesome. And I wonder if Anne doesn't have maybe a little technical problem. I know I left you with some frozen screens I didn't like.
Uh-oh.
It's all good. I'll reach out to her. All right. Day 2 of a virtual conference. Something's gotta happen, right?
Always.
We've been lucky so far. So, you know, I hope I wasn't jinxing everything here. Let me pull the slides. Luckily, I have them, and maybe I can already get them up while Anne, I think, might be coming back.
She's texting me that she's got some screen loading issues.
All right.
There she is.
It was stuck on loading.
Yeah, totally fine. No worries at all. Let's see if your sharing works, and then I will give you the stage. And I think we just lost Bogie.
Ooh.
Fantastic. Here we go.
Okay, and now I cannot see the main stage since it's in a different tab.
Yeah, if you want to put your, I don't know how you want to do it, but we see all the slides. Again, not sure if you want to go in presentation mode or not. That is your personal preference. Here we go. Now we see your slides in presentation mode. Perfect. And Bogie is back. You're all set. If you need me, I'll be here.
Okay, are we live?
We are live. Take it away.
Amazing. Good morning, everybody. Welcome to day 2 of the TIPE conference. We're Girl Gang Garage. My name is Anne, and I'll be welcoming Bogie Latainer and Pam Waterman to join me in talking about how we integrated 3D printing with the Iron Maven vehicle build. So my name is Anne. I got into 3D printing several years ago through open source printer building, which at the time was kind of the most accessible way for me as a student to get into 3D printing. And after doing that, I started using 3D printing to build my prototypes, build my robotics, and ended up going into a master's in additive and robotics. So following this, I went into product development, worked at several different companies, and now I use 3D printing to help transition products at Google from prototype stage all the way to mass production. On this Iron Maven build, I was focused on the CAD modeling for all of the prototypes as well as the end use parts. So Girl Gang Garage is an amazing organization founded by Bogey. She had been working in the automotive industry for a long time. So she's coming in with that technical expertise, as well as that business expertise, and then translated that into helping other women in the industry, as well as women who were interested in the industry, to have opportunities to connect with each other and learn. And so Girl Gang Garage now hosts more than 200 women a year in various project builds, as well as creating lots of professional development opportunities, including learning about 3D printing and CAD modeling. So the Iron Maven build, which is what we're talking about today, is a really slightly insane build. So this car is a 1961 Volvo PV544. This body was taken from right outside of Phoenix, which is where Girl Gang Garage is located. And the body of the car is even a little bit old style for 1961. It's a very, very kind of classic car style, very curvy body. And so basically what this build is integrating this 1961 classic car body with the chassis, the drivetrain, and all of the modern electronics of a 2019 Volvo S60. And I love this quote because this just clicked for me. Like basically the reason that this build is so interesting and so crazy and so difficult is that we're integrating electronics and the chassis and everything from a much, much bigger vehicle into this teeny tiny little classic car body. So basically think about squeezing a new Volvo sedan into a classic Volkswagen Beetle and you'll get the idea. So how did we get involved and how did 3D printing come into play? So Bogey wanted to incorporate 3D printing and was connected with Stratasys to support the 3D printing side of the project. So Stratasys came on as a sponsor, which is how Pam got on board, as well as Girl Gang Garage getting a printer to use on site for prototyping and production parts. So once Pam was on board, she reached out to her Women in 3D Printing network, and that's how I got on board for the project. And once I was on board, I knew we needed a CAD software. I knew we needed support for not only actually doing this build, but creating those educational opportunities. So we brought on Autodesk to support CAD and education for the CAD and design software. So just to give a high-level view here of what the timeline was, this was an almost 2-year-long build. So this project started at the beginning of 2021. We brought on Stratasys very early on. Women in 3D printing became involved very early on. And then in 2021, we were very focused on the 3D scanning part of the project. So doing lots of scans, figuring out the workflows for taking that data, coming up with designs off of it, and figuring out what types of parts we really wanted to focus on for this vehicle. And so once the teardown started and we started getting a better idea of what kind of parts we really needed for this project, we ended up focusing more on parts that replicate production parts. So we didn't want the 3D printed parts to stick out like a sore thumb on the vehicle. We wanted to use 3D printing to make these parts that perfectly match the style of the vehicle and were parts that we never would have been able to get off of the shelf for this custom build. And so in the middle of 2022, I had the awesome opportunity to work on site at Girl Gang Garage for about a week and a half total. And we just worked all day, every day, iterating quickly, running the 3D printer, making parts, testing them, making a new part all day, every day. And then in November 22, the vehicle was unveiled at SEMA show in Las Vegas. So in residence at the Girl Gang Garage shop, I was able to work on all the CAD models and do really, really fast fit checks and changes and take lots and lots of selfies and connect with all of the amazing women that were coming in from not only all over the US, but from other countries as well, just to work on this project.
There no audio with the video. It remains super cool, even without the sound. I'm not sure if someone was talking on the video, if there was music.
Is the video sharing?
Lost the video.
No.
It didn't have audio.
It didn't have the audio.
Oh,
Yeah, sorry. You want to try again? We now have the share video option on the right corner. I think it's worth trying again if you want. Awesome.
are we good? There we go. Are we back on my screen?
Yes.
Amazing. So now I want to invite Bogey to take the stage and talk more about Girl Gang Garage's mission, her background, as well as the amazing SEMA reveal event.
Thank you so much, Anne, for introducing the project a little bit and Girl Gang Garage, and thanks for having me here. I'm really excited about this. So I've been an automotive technician for about 25 years now. I started out not into cars, honestly. I started out as a pre-law student, and I had the dreams of going and supporting women through kind of legal system and making change to the laws and that kind of stuff. But I got really bored of the academic world and really burned out on that. And I really missed working with my hands, which is something that I'd kind of fallen in love with in high school when I got my first car. And so I decided to pursue auto mechanics, and I wound up finding my way to using automotive information and knowledge to empower and educate women. So kind of still keeping that goal about really supporting women and empowering them and creating change for women, but doing it in kind of a different way. So Girl Gang Garage really came about, as Anne said, and as the video said, out of a desire to alleviate a lot of the challenges that I experienced coming up in the industry. I came up in the industry, I guess, 25 years ago when women were an even smaller minority of technicians. And so it was incredibly isolating, and there you just rarely ever met any other women doing the work. And so I wanted to create a space where women could come together and where we could push ourselves and learn more and challenge each other and create community, but also where we could kind of on a very large scale challenge the rest of the industry's assumptions and presumptions about about women in the automotive industry and what we're capable of. So the idea of these all-female builds came around to display on a national stage, i.e. SEMA, which is if you're not familiar with SEMA, it's like the Super Bowl of car shows every year in Vegas. And it was an opportunity to put all of these women on that stage and say, like, look what we can do, look what we can build when given the opportunity. And kind of eliminate those questions that so many men in the industry have, that, well, are they really capable? Can they really do the work? Like, let's just show it off on a really big stage and take on these really ginormous projects. So the Iron Raven was the third project, is the third all-female build that we've done and completed just this past year. Definitely the most ambitious and the most challenging. It is probably the most... it's the most insane build I've ever done, period. And I think, whether it was an all-female build or not, it's an incredibly challenging build for anybody to take on. To take on a build like this with all women, with women from all over the country, and with about 30% of those women being total newbies, that was definitely incredibly ambitious. But because it was such a weird build, right? Brand new car being mashed up with a little tiny old car and trying to figure out how to make everything work. There were needs that were not going to be solved in a traditional way. And so 3D printing was a game changer for us. And we didn't know anything about it, really. I knew about 3D printing. I knew I was excited about it conceptually. I like the idea that 3D printing really changes the accessibility of car builders to be able to manufacture their own parts and design their own parts and do things that otherwise would not be possible. But I had no experience with CAD. I had no experience with 3D printing. And so this was really my first foray into it, and same with so many of the women involved in the build. So again, kind of keeping that idea of pushing ourselves, learning new things, celebrating really old technology, but also celebrating really new technology, celebrating old cars, celebrating new cars, kind of mashing all of it together. And it was just such an incredible experience. A little dangerous, I have to say. Learning CAD design is a little dangerous because I've always gotten myself into trouble with this idea that I can make or do anything if I put my mind to it. And now adding 3D printing to the mix, it's like, oh, wow, now I'm really going to get myself in trouble with, oh, it's easy. We'll just make it 5 weeks later. And throwing up the slide here on 9.6% of automotive repair. It is across the trades, actually, women make up about 10% or less than 10% across all of the kind of hands-on trades. In the automotive industry, that 9.6 number is actually, it's high because it includes like lube technicians and kind of more entry level and really, you know, basic stuff within the industry. If we look strictly at technicians, automotive technicians, generally, we're looking at about 2.5% or less than. It kind of has fluctuated over the years. But there is change happening, right? When I first started in the industry, women made up 1.8% of all automotive technicians. And that number is rising, and in part, I believe, due to visibility. So we've done 3 all-female builds now. SEMA Business Women's Network has done a couple of all-female builds. There's some other small groups around the country that have done little projects. But I think really creating that connection between women within the industry reinforces their stick-to-itiveness, I guess, when it comes to staying in the industry. Being isolated, as I'm sure many women in engineering can also relate, women in 3D printing can also relate to this. It can be incredibly isolating, and when you don't have that support system, when the going gets tough, it's easier to want to leave and to give up and go do something different. So the increase in opportunities like this, where women can connect with one another, where they can meet one another and really experience that they're not alone, that they are being validated, that they are being valued and being celebrated, really increases their numbers and their desire to stay within the industry. And it increases my own desire to stay within the industry, in all honesty, right? Having all of these women around me is just always that boost of energy that keeps you going. What's our next slide? There we go. So the show reveal. This was. Do we have audio for this? There we go.
I think we're okay without audio.
Okay. So this was a huge moment. Obviously, we had about 30 to 40 women who were involved in the build. We're here at SEMA for this unveiling. The cheering was just incredible. I would hear from people for the next several days that they could hear us yelling and cheering during this unveil all the way across the showroom floor. And there's something that is just so difficult to explain, to have all of these women gathered around this car that they all poured their heart and soul into, to see the final results of it, to see the response from the media and from the rest of the folks at SEMA. It's an unbelievable feeling. It's an unbelievable accomplishment. And it's really, I don't know. It's inspiring, even having been involved in it every step in the way, even being the person behind it. There's just something so inspiring about seeing all those women come together to build this project that nobody thought was possible, and that would not have been possible had we not all come together, if that makes sense. So there she is, beautiful Iron Maven, mashup of a 2019 S60 hybrid and a 1961 Volvo PV544. You can tell we made some really dramatic changes to the PV544. Everything on this car is custom, and it really was a celebration of old and new, celebration of where we started and where we finished and where we're going, right? This is really, the entire project was celebrating where women have started in the industry to where they're at now and what we hope for them for the future, where technology has started doing hand forming metal work, and then where we're going with using CAD design to 3D print parts that are one-off, unique parts, and just celebrating old technology and new technology. So all the way around, this is a celebration of old, new, and future. And you can see the dramatic differences between these two vehicles and where we ended up. And hopefully the future what we're bringing in, I think, is going to be as much of a dramatic difference as this was. I hope to see more and more women entering this industry, more integration of 3D printing. I think technology is incredibly exciting and creates so many opportunities for women to get involved in an industry that is still so incredibly male dominated. So it's exciting to me to see more and more 3D printing being incorporated into car builds and automotive work.
Thank you so much, Bogey. So now I want to bring Pam Waterman onto the stage. So Pam is talking about the 3D scanning part of the project.
Hey, Anne. Hi, everyone. I've got to tell you, I'm so excited to have been a part of this and to get to continue sharing it around the world this way with this talk this morning. I work at Phoenix Analysis and Design Technologies. It's an engineering services, analysis, design, manufacturing company outside of Phoenix, Arizona in the States. And I got brought into this totally unexpected. It's one of the great things about my job. You just don't know what the next day is going to bring. But we are resellers for one of the manufacturers of polymer printers called Stratasys. I got a call from Stratasys, some of the higher ups, one day in January of 21, and they said, there is this woman who has an all-female garage project where she's restoring cars. She's approached us. She knows Jay Leno. She knows people in the automotive industry. And she thinks she wants to get into 3D printing as a new tool to help her with all of her old school skills. And they thought they would work with her. Sounded like a great idea, kind of win-win for everyone. Because we are the local reseller, since she is also in Phoenix, they wanted me in on the project, our company, our resources, not only to support the 3D printer, which you see there in the picture that went on site, but also because my company as a service uses and sells 3D scanners. So my background quickly is in microwave engineering, my first career. Got a master's in it, loved working with it. Then life got busy. I kind of moved sideways into technical writing while I raised a family. And during that phase of my life and my career, I was introduced to 3D printing 25 years ago. I thought it was phenomenally exciting and kind of put that in the back of my mind that when I got back, when I had the chance to get back to hands-on engineering, that would be the field I would choose. And I knew the PADT company, the people here are great, so I've been really lucky to work with them. However, this bit with the 3D scanning, even though I knew about it, had gotten to write some articles about it, I wasn't hands-on with it the way I was with 3D printing until that exact same month. So kind of funny thing was I literally had 2 weeks notice where I was going to go in and scan this car. The pictures there show the scanner. I have my handheld scanner here. I'll talk a little bit more about it in a minute. But I thought, okay, how am I going to practice? So I got to scan a car, right? So I got out my handy radio controlled model car. I scanned that at home, got a little practice, and then went in. Another funny thing is, small world, I realized I had met Bogey 15 years previously. My daughter was learning to drive, and Bogey was doing these amazing sounding Car 101 workshops to introduce women to just car ownership and changing your oil and checking things and changing a tire. And it was just so cool to realize this was the same woman. She was moving on to even hugely bigger and better things, and I would get to be a small part of it. Okay, Anne, next slide, please. So what it required is we needed to capture the what we call a digital twin. We wanted to acquire data for this one-of-a-kind vehicle project because, as Bogey said, we needed to have information to allow us to make changes. None of the things that we were going to do were just off the shelf, you could order it. And the starting point for making decisions on what the new parts would look like would be to have data that we could bring into a CAD program and then edit and manipulate. So the 3D scanner that I use, it's handheld. It's based on two kinds of laser transmissions. different wavelengths that give you different kinds of information, but it creates millions of points in space. Literally, it's just giving you an XYZ coordinate point. It creates what we call the point cloud that captures the shape over on the outside of the body of the car, on the inside of the body of the car. We also scanned the new car coming in. We've zeroed in on small components. You can do fine details like the door handle or the overall. And we were able to merge that data and convert it into what's called the standard STL mesh file format. But I knew that after acquiring the data, creating this digital twin, there was a workflow that had a few extra steps before you could just hit the button on the printer. And that's where it was astoundingly wonderful that Anne was able to come in with her CAD knowledge and translate information, whether it was data that I had interrogated just to get measurements and dimensions, like what's the distance between two hole centers where we had to mount something, or whether it was the actual STL mesh file that we were able to convert kind of to a surface. And then Anne would change it into an actual solid model that could be edited, because that's the key. We knew we were going to make changes. We didn't just want to capture what was there. So there were a lot of steps involved. As Anne said, throughout the process, we had to scale down a little and figure which elements were we going to focus on and work with that. So next slide. This gives an example showing when I did the underside of the body. The scanner is made by Zeiss GOM. As I said, it's a laser system. And first we had to capture reference points. It was kind of funny. It took several hours with several of us with little sticky reflector dots, but those are very critical. So you establish a reference system, a frame of reference for all of the different angles. That's what allows you to move the scanner by hand while you're going all around this system. And then we were able to interrogate the data, pull measurements, and take subsets for moving on to the next steps. Next slide. Having gotten that data, then with Anne's help and several other people, we had an amazing CAD Tiger team, we called it. We were able to do some experiments first, just printing a few elements as we found them. So there's Bogie and Shonda working with the F370 printer. It's a filament type printer right there in the garage. The car is behind us. And in that case, we did a prototype just of one of the mechanisms of the handle, just to start with, and then use that visually comparing what the hole spacing was, what was the decorative handle cover that went over it, back and forth, making creative design judgments and decisions, and going through that whole iterative process. So the FDM printer worked great for both prototypes and some of the final parts that Anne will be talking about. And then also I had access to another Stratasys printer that uses a different additive manufacturing technology that is called DLP. It uses a liquid resin rather than a filament, and it's cured with a UV light. That produces parts with a little bit finer finish. So there you're going to see it's a part. I did one in black. It prints upside down. And then this is a sacrificial support material. Here's my nice smooth antenna cover. Again, you'll see more of that. And we made sure that the fit checked and did some really, really cool 3D printed FDM test parts, whether it was a clip on the handle or something testing the curvature of this antenna cover. How well would it fit onto the roof line, putting it in a place where it was never before. And then finally, we printed this last one in a different resin because we needed it to hold up to extreme temperatures in Phoenix and in other places. So we used some judgment about what materials to use along the lines too. Okay, next slide.
Awesome.
And
thank you so much,
I think
Anne.
that's Anne. Up to you now. Take it away.
Great. So I'm going to talk through the highlights of the parts that we worked on here. So like I said, our goal was to replicate these parts that for some vehicles you might be able to buy off the shelf. But for this build, because it was so unique, all of these parts had to be custom. So for the exterior, we had door handle, the antenna, and all of the camera mounting and casing. And for the interior, we actually built an entirely custom cabin air duct, as well as a suspension adapter, which is maybe my favorite part, even though in a lot of ways it's a little bit hidden, because this is the part that Bogey made after taking her first CAD workshop. So the door handles, we created this custom component that not only fit this car style-wise, but it also fit this modern mechanism and integrated the lighting and proximity sensor. And so the PV544 didn't have this modern door mechanism. So we combined the S60 door mechanism with that body. And so the S60 mechanism was much, much, much bigger scale-wise than what made sense for the PV544. And so we took that mechanism and took a lot of that material off. And in order to create this part, Pam 3D scanned that mechanism that had been modified, and there were some really, really critical snap points that had to be perfect for this handle to snap onto the vehicle and not be too tight, not be too loose, and also fit all of those components into it. So using this 3D scan, we were able to grab those mounting points out of the CAD and really quickly, with only a couple fit checks, get that perfect snap-on fit. And so then came iteration. So we went through several rounds of iteration to get this handle as small as we could. We're actually still iterating on it. So there might be a new door handle on it the next time you see it. But I just got used to every time we printed a part, Bogey would say something along the lines of, okay, this is great, but can we make it smaller? And so this was an extremely iterative process. And then the final part was printed on that Stratasys FDM printer and then finished to look like a fully, off the press production part. The second and third parts are this shark fin antenna and the camera cover. So these are also very aesthetic parts that had to be custom, both to fit the style and to fit the body. And so both of them integrate these modern electronics. And so we had to both fit the outer body of the vehicle, but also do lots of fit checks in order to get the part as tight on this component as we possibly could. So taking all these 3D scans of the antenna module, which is the electronics module that has all the antenna components, this CAD screenshot is actually a layered view showing the 3D scan and a stepped back side view of the vehicle. So combining these two things, we were able to use that 3D scan to make the interior geometry of the antenna cover, and then use images to track the outer surface of the vehicle. You can't see it in that picture, but there's somebody hunched inside the trunk of the vehicle holding this up against the roof. And then just like the door handle, lots and lots of iteration, lots and lots of Bogey asking me if we can make it just a little bit smaller. And then the final printed parts were printed on an Origin resin printer and the FDM printer. And then the final ones that I wanted to show you are more functional parts rather than aesthetic. So the cabin air ducting, the module that was coming off of the S60 for the air duct, it was way too big than we could fit in the space on the 544. And so you can see that coolant tank sitting there. The original module probably filled almost all the space that coolant tank is sitting in. And so we had to not only create this custom component that had that had a completely different envelope, but we also rerouted the air intake to a completely different part of the vehicle. It originally pulled in air from the top of the hood, but the 544 just does not have an air intake in that location. So this fully custom component solved multiple problems for us. And then this custom suspension adapter, it's the same thing. The 544 was so much smaller than the S60 that it needed a completely different suspension that was much shorter. And that completely different suspension required some way to bridge the gap and create an adapter between those two threaded parts. And this adapter just does not exist. It had to be a custom part. And so on this one, instead of 3D scanning, we used reference dimensions that were pulled off of the vehicle as well as pulled off of imaging to come up with a rough model of what was happening in that engine, and then iterating it and printing the final parts. So both of these parts were printed in ABS ASA on the Stratasys F360 printer. And you know, I don't know about you, but if I looked at that, I would never guess it's a 3D printed part. They did such a good job finishing these parts. You know, that's what happens when you have professional automotive technicians finishing a part. It looks so much better than I could have ever made it look. So I want to bring Bogey back to talk a little bit about what's happened since SEMA and just what's next for Girl Gang Garage.
Yeah, so we are taking a pause on doing large scale builds like the one that we just completed. It is amazing and exhilarating, but exhausting and takes everything out of me. So we're taking a pause on that. And the focus this year is really going to be on educational opportunities, more opportunities, hopefully with Autodesk and with Stratasys doing some more learning in that arena, but also bringing groups of women to various places where we can get specialized education, doing some smaller scale projects, but really focusing on education and on community, and less on the intensity of a massive deadline like SEMA. So the connection, the community, the learning will continue. Hopefully we will actually get to sleep this time though. So that is the plan for Girl Gang in the future. And we are all available for some questions and answers if anybody has any for us.
Yes, there are some really good questions, but first, thank you so much to the three of you. I think you probably haven't seen the chat so much in the last 30 minutes, but people are really excited. So thank you. I think we were, again, all excited to hear more about a project that we may have heard of, you know, here and there on LinkedIn, but like getting a chance to really hear from all of you on the insight on project. It's amazing. So thank you. And yes, Bogi, I can only imagine like how much energy goes into a project like this. So yeah, kudos to all of you for making it happen. So we have time, but we'll have really good questions. I will take the first two that we have in the Q&A panel here. And we already warned for everyone who's watching, we already warned our track moderators to delay a little bit the sessions. So if you want to stay to hear the answers to the questions, please do so, and we will resume the sessions a little bit later. Okay, so first question from Sam. How much of your work is new design versus production of existing, perhaps vintage parts? Great question. Can you discuss the tools, software you use to scan and develop 3D models to get them ready to send to 3D printers? I think the second half has been already touched on, but let's maybe go on the first half. Yeah, so how much is new design versus production of existing and perhaps vintage parts?
There was no production of existing or vintage parts at this point. This was all custom one-off stuff that was very unique to this situation in this project.
Awesome. Well, it makes it even more impressive, I guess. And second question here from Michael, how do you see this sort of project aligning with sustainability, given that we are peaking in terms of natural resources, and this could be an opportunity to recycle materials for automotive? Great question.
Yeah, absolutely. I think, it all fits together. There's a lot of energy and buzz around putting hybrids and electric platforms into older vintage vehicles. And I think the excitement there is, how can we be better for our environment and yet still enjoy our love of old cars and appreciate the beauty and the artistry of old classic vehicles without completely destroying the. And so I think this is part of that. I think, one of the things we're proud of on this particular build is that we used relatively little new material. I mean, the S60 obviously was a new vehicle, but we didn't really buy a lot of parts for it. We made what we needed. And even with the metalwork and customizing, we used as much of both of the cars as we could. We were constantly scavenging. It was very normal to hear me in the shop saying "reduce, reuse, recycle" as we went and pillaged and plundered and scavenged things off of the S60 or metal from the disposed part of the PV54 that we didn't need. We're like, oh, we need some metal for a patch. Well, can we steal this from there? We need a bracket. Can we steal this from there? Where can we take and reduce and readapt and repurpose?
Yeah, I'll chime in on this too, because operations is kind of my wheelhouse. Like 3D printing has a lot of potential to make an impact from a sustainability perspective on these custom automotive parts, because a traditionally manufactured custom automotive part, it's made using, permanent tooling, which probably already was made for the original vehicle. But then after that, it's taking up space in a warehouse for decades, potentially, before somebody is actually using it. And then even after that, then you have your shipping costs and your logistics costs. And so 3D printing does have the potential to have a sustainability impact just by reducing that warehousing and that shipping and logistics.
Yeah, really good point as well. Awesome. Well, thank you so much. Unfortunately, we have again a few more questions here, but we will a little bit over time, so we're not going to be able to take them. Is it fair to say that you can stay a little bit more around on the main stage if people want to find you and ask questions?
Can I pull out one question here? Someone asked, is Iron Maven making it to Barrett-Jackson?
Sadly, no. Maven got hurt during transport, and we are in the process of fixing her. So no.
Oh. All right. Well, again, thank you so much. You're all welcome back on the stage anytime. Thank you. All right. For everyone else.